Okay, good evening. So today we will discuss some problems in recurrence relation. So I already written the problem, and then here I shared the problem here. Okay, so the problem is an equal to 4 into an minus 1 minus 4 into an minus 2 plus 4. Maybe I will write the problem in the. Okay, please write. Okay. an minus 4 an minus 1. Okay. So use the method of generating function to solve the recurrence relation an equal to 4 into an minus 1 plus minus 4 into an minus 2 plus 4 power n. So this is a problem where n is greater or equal to 2. Given that a naught equal to 2 and a1 equal to 8. Okay, so this is a given problem. So first you should take the generating function of the sequence an. Okay, the sequence an be g of x is equal to summation n equal to 0 to infinity an into x power n. So what is g of x? G of x is summation n equal to 0 to infinity uh, an into x power n. So this is your generating function. Okay. Now first you should write everything in the left side. Okay. Or you can keep as it is, no problem. So usually I will write like this. So minus 4 into an minus 1 plus 4 into an minus 2 minus 4 power n equal to 0. Now multiply each throughout x power n and taking the summation n equal to 2 to infinity. So n equal to 2 to infinity an x power n and then minus 4 into the summation n equal to 2 to infinity an minus 1 into x power n plus 4 times summation n equal to 2 to infinity an minus 2 into x power n minus summation n equal to 2 to infinity 4 power n into x power n is equal to 0. Okay. So now next what you need to do here, this is x power n. X power n. So here this power n, this n should be saved. So okay, first of all, okay. So but here have n, here n minus 1, here n and n minus 2. So first I am going to adjust these two. I think here it is fine. Okay. So the next I will write summation n equal to 2 to summation n equal to 2 to infinity an x power n And from this I will take what? Make it, this is what? X power n minus 1. That's why I'll take x common, minus 4x into summation n equal to 2 to infinity a n minus 1 into x power n minus 1. Okay. Next, here I should, this should be n minus 2. So take x square common, plus 4x square summation n equal to 2 to infinity, okay, a n minus 2 x power n minus 2, okay, and then summation, if we substitute 2, we'll get what? 4x whole square, okay, 4x whole square, and then 4x whole cube, and so on, plus dot 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 equal to 0. Okay, now here this is start from the third term, that is a2, because you can see here, this is first term is what? A naught. Second term is a1x. Third term is what? A2x square. So this is start from where? Third term. So suppose if I write this one is summation n equal to 0 to infinity a n x power n. Suppose if I write this one, I need to subtract what? I need to subtract uh, first term, that is what? A naught minus a1 x. Okay. Now minus 4x. Okay. Now if I substitute n equal to 2 here, what you will get? I will get the term from where? I think n equal to 2 means you will get what? A1 x. So that is the second term. First term is not here. Okay, that's why I will include the first term here. That is n equal to, just to rewrite, n equal to 0 to infinity a n x power n. Okay, minus. So if it is if it is a n x power n means what? This contains the first term as first term. Okay, so I need to subtract what? Uh, the first term. First term is missing here. I included the first term here. So a naught I should subtract. Okay, now plus 4x square. So this contains what? From the first term, because a naught. This is the first term. A naught x power 0 is 1. N equal to 3 means what? A1x. So this contains everything. So that's why I will write, instead of 2 to infinity a n minus 2 x power n minus 2, I will write n equal to 0 to infinity a n x power n. So both of them are same. Okay, this is same as this series, minus, make it 4x whole square common, okay, should make it, this position is 1, so that's why I'll take 4x square common, remaining what? 1 plus 4x plus 4x whole square plus and so on, equal to 0. So now this is what? G of x minus a naught. A naught is I think 2. A naught is 2. A1 is what? 8 minus 4x into this series is g of x minus a naught is 2 plus 4x square. Again, this is what? G of x, which is equal to this. This is coming to right side. So 4x square into actually what? 1 minus 4x whole power minus 1. I will write the denominator. 1 minus 4x whole power minus 1. Actually, you should write what? Equal to 4x square into 1 minus 4x whole power minus 1. I don't have enough space. That's why I'll put it in the denominator here. So actually, I need in the denominator only. So, okay. Next step, I'll take g of x common. If I take g of x common, next step I'll write. G of x into 1 minus 4x plus 4x square. 1 minus 4x plus yes, plus 4x square, yes. So remaining everything I'll write on the right hand side. So here I think you can minus 2. Okay, I'll write minus 2. Okay, minus 2 minus 8x plus 8x. That is 0. Okay, I'll write minus 8x plus 8x, which is equal to 4x square divided by 1 minus 4x. Okay, now this is g of x into 1 minus 2x whole square which is equal to 2 plus I think this is 4x square, 4x whole square. 4x whole square means what? 16x square. 16x square. Okay, and then 16x square. Okay, here also what? 16x square. Okay. Now 2 plus 16 x square divided by 1 minus 4x. So if you take LCM, you will get g of x is equal to, okay, if you take LCM, what you'll get? 2 minus 8x plus 16x square divided by 1 minus 4x. So g of x is equal to 2 minus 8x plus 16x square divided by 1 minus 4x into 1 minus 2x whole square. Okay, now you should apply partial fraction. Okay, here. So 2 minus 8x 2 minus 8x plus 16x square divided by 1 minus 4x into 1 minus 2x whole square. Into 1 minus 2x whole square, which is equal to, you can write this is a by 1 minus 4x plus b by 1 minus 2x plus c by 1 minus 2x whole square. Okay, now using partial, you can get the values. I'll write the values directly. Okay, you can check it. A equal to 4, b equal to 0, and c equal to minus 2. So now g of x is equal to Okay, so actually g of x is equal to this expression. So directly write 4 by what? 1 minus 4x, b 0, c is minus 2 by 1 minus 2x whole square. So which is equal to uh, 4 into, right, this is 1 minus 4x whole power what? Minus 1 minus 2 into 1 minus 2x whole power minus 2. This is g of x. Now the next step, compare the coefficient of compare the coefficient of compare the coefficient of x power n on both side. Okay, on both side. So what is okay? First, you should expand it and then first expand. If you expand this, what will get? 1 minus 4 into 1 minus 4x. 4 into 1 minus 4x is what? Whole power 1 plus 4x plus 4x whole square plus and so on plus 4x whole power n plus so on, and then minus 2 into 1 minus 2x whole power minus 2, 1 plus 2 into x is 2x plus 3 into x square, x is what? 2x whole square. So what is the nth term? Nth term is n plus 1 into n plus 1 into 2x whole power n plus and so on. Okay, now you can write compare the coefficient of x power n. Okay, here what? G of x. So compare the coefficient of x power n on both sides. So what is the coefficient of x power n? The left hand side, a n. Okay, now what is the coefficient of x power n here? 4 power n. So 4 into 4 power n, okay, minus 2 into n plus 1 into 2 power n. So an is what? Final answer, an is equal to 4 power n plus 1 minus n plus 1 into 2 power n plus 1. So this is the final answer. Okay. So next problem. Uh, so use a method of generating function to solve the recurrence relation. Okay. An plus 1 minus 8 into an plus 16 into an minus 1 equal to 4 power n, where n greater than or equal to 1 and a not equal to 1 and a1 equal to what? 8. So maybe I'll write here the problem. So use the method of generating function to solve the recurrence relation an plus 1 minus 8 times an plus 16 times an minus 1, which is equal to 4 power n, where n is greater than or equal to 1 and a not equal to 1 and a1 equal to 8. a1 equal to 8. So you should write first g of x. What is g of x? The generating function n equal to 0 to infinity n equal to 0 to infinity an x power n. So write everything in the left hand side and multiply by what? X power n, and taking the summation n equal to what? 1 to infinity. So I'll do it everything in a single step. So an plus 1 into x power n minus 8 into summation n equal to 1 to infinity an into x power n plus 16 into summation n equal to 1 to infinity an minus 1 into x power n. Okay, and then minus summation n equal to 1 to infinity 4 power n into x power n, which is equal to 0. Okay, now next here is to compare the power, and this suffix n here also n, it is fine, no problem. But here n plus 1, here n minus 1. I will do some adjustment here and here. Okay, now here you can't change anything, so here only I should change into n plus 1. So suppose if I need here n plus 1 means divide by 1 by x, 1 by x summation n equal to 1 to infinity an plus 1 into x power n plus 1 minus 8 into summation n equal to 1 to infinity an into x power n minus, make it, this is n minus 1, so that's why I'll take x commonly here, plus 16x summation n equal to 1 to infinity an minus 1 x power n minus 1, and then if you start from 1 now 4x, and then 4x whole square, 4x whole square, 4x whole cube, and so on, which is equal to 0. Okay, now 1 by x, next to 1 by x, here it is starting from again what? A2. A2 is what? Here third term. A2 x square is what? Third term. Okay, if I write this is g of x, if I write this is directly g of x, g of x means what? This summation. In the last problem I wrote this summation and then I wrote g of x. Here I simplified one step. Okay, directly I will write g of x. Here it start from there, a third term. But in g of x, you have all the terms. So that's why I need to subtract the first term, a naught minus a1x. Okay, minus 8 into minus 8 into, here it start from the first term. Okay, well, not first term. A1 means what? Second term. A1 x is what? Second term. Okay, well, if I write this is g of x, so I need to subtract the first term. What is the first term? A naught. A naught is not here. A naught is not here, but A naught I included here. It is there. That's why I'll subtract here. Okay, and then plus 16x. Look at this one. So here I have A naught, first term. N equal to 1 means A naught. N equal to 2 means what? A1x. So I have everything. So this is equivalent to this summation. Okay, wow. This summation, these summations are same. So directly you can write what? 16x into g of x. 6 plus 16x into g of x, which is equal to, I'll write, okay, equal to 4x if you take common. Okay, 4x if you take common, 1 plus 4x plus 4x whole square, and so on. Okay, Now this is equal to throughout multiply by x. So g of x minus a naught. I think a naught is 1, a1 is 8 minus 8 into throughout multiply by x into g of x minus a naught is what? 1 plus 16x into g of x, which is equal to 4x into 1 minus 4x whole power minus 1 or divided by what? 1 minus 4x. Now collect the terms which contains g of x separately. 1 minus 8x plus I think here it should be 16x square. Yeah, throughout multiply by x means 16x square plus 16x square. Okay, minus 1. If it goes there, plus 1. Okay, minus 8x plus 8x gets cancelled. So 1 plus 4x by 1 minus 4x. Okay, so now next step I'll write g of x into this is what? 1 minus 4x whole square. 1 minus 4x whole square, which is equal to, if I take LCM, I'll get what? I think still I think okay, I done the mistake here, because throughout multiply by x means here also I think yes, I took 4x commonly, so throughout multiply by what? Okay, I 4x commonly, throughout multiply x means here 4x square. Okay, so 4x, so throughout multiply by x means 4x square, here 4x square. So g of x into 1 minus 4x whole square. Uh, okay, if you take LCM, 1 minus 4x plus 4x square. 1 minus 4x plus 4x square divided by 1 minus 4x. Okay, 1 minus 4x. Now g of x is equal to 1 minus 4x plus 4x square divided by 1 minus 4x whole cube. Or you can write g of x is equal to 1 minus 4x plus 4x square into 1 minus 4x whole power minus 3. So now before going to expand this one, maybe you know that 1 minus x whole power minus n formula, which is equal to 1 plus nx plus n into n plus 1 by 2 factorial into x square. Next term is what? N into n plus 1 into n plus 2 by 3 factorial into x cube plus x cube plus and so on. So if I substitute n equal to 3 here, 1 minus x whole power minus 3, which is equal to 1 plus 3x. Okay, 3 into 4, 12 by 2, 6x square. Similarly, you can write all the terms. But using this, you cannot easily find what? The coefficient of x power n. So that's why I will rewrite 1 minus x whole power minus 3 is, I will take I'll take 1 by 2 common. One, okay, then it should be what? 1 into 2, 2 into 3 into x plus 3 into 4 x square, because 12 by 2 is what? 6. It goes like this. Okay, plus dot 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 plus, what is the coefficient of x power n? Coefficient of x power n is n plus 1 into n plus 2. And then plus, so this is 1 minus x whole power minus 3. Okay, now in the previous one, I think you have g of x is equal to what? G of x is equal to 1 minus 4x plus 4x square, minus 4x plus 4x square. Okay, 1 minus x, 1 minus, instead of x, I have 4x whole power minus 3. Okay, so 1 by 2, it is 1 by 2 into what? 1 into 2 plus 2 into 3 into x plus 3 into 4 into x square plus dot 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 plus okay, x power n minus 1, x power n minus 2 terms I need. X power n minus 2 term if I need means here it should be what? I should add 1. So n minus 1 into n. Okay, why I need x power n minus 2? Because here I have what? X power term. If I multiply, then only I get what? X power n. Similarly, if I have x term, I need here x power n minus 1 terms also. So n into n plus 1. N into n plus 1. Oh, sorry. It should be what? 4x because 4x whole power n minus 2. Here I should write what? Instead of x, I should write what? 4x. 2 into 3 into x. But here, instead of x, we have what? 4x. Okay. And then here, 3 into 4 into 4x square. Plus dot 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 n minus 1 into n into 4x whole power n minus 2. N into n plus 1 into 4x whole power n minus 1. And nth term, okay, coefficient of x power n plus 1 into n plus 2 into 4x whole power n plus dot dot dot. Okay, now you should compare what? Compare the coefficient of x power n. So what is the coefficient of x power n in the left hand side? An, which is equal to 1 by 2 is common, 1 by 2 into, so 1 into this term, so n plus 1 into n plus 2 into 4 power n plus 1 into n plus 2 into 4 power n. Okay, next to minus 4 into minus, so minus n into n plus 1 into 4 power n minus 1 into 4 is what? 4 power n. So minus n into n plus 1 minus n into n plus 1 into 4 into 4 power n minus 1 is 4 power n. Okay, next here plus plus plus, so n minus 1 into n plus n minus 1 into, so 1 by 2 is common, n into here 4, here 4 power n minus 2, so 4 power n minus 1. Now, I think what is common here? 4 power n minus 1 is common. Take it out by 2 n square plus 2n plus n 3n plus 2 minus 4 into n square plus n, and then plus n square minus n. So simplify further, an equal to 4 power n minus 1 by 2. Okay, I think I done the mistake. What's a mistake? I think here 4 power n minus, yes, 4. It should be into 4. Okay, 4 n square. So 4 n square minus 4 n square gets cancelled. Okay, so write 4 n square plus 12n plus 8 minus 4n square minus 4n plus n square minus n. So these two gets cancelled. n square, so an equal to 1 by 2 into n square plus 7n plus 7n plus 8. N square plus 7n plus 8 into 4 power n minus 1. So this is the final answer. Okay. So now I will move to the next problem. Next problem is use the method of generating function to solve the recurrence relation an equal to 4 into an minus 1 plus 3n into 2 power n, where n is greater than or equal to 1 and a not equal to what? 4. We'll write quickly. Third problem. Use the method of generating function to solve the recurrence relation an equal to 4 times an minus 1 plus 3n into 2 power n, where n is what? Greater than or equal to 1 and a not equal to 4. Okay, now solution. So g of x, the generating function g of x is equal to summation n equal to 0 to infinity an x power n. Now I'll write as taking the summation, okay, an into what? Throughout multiply by x power n and taking the summation n equal to what? 1 to infinity minus 4 times summation n equal to 1 to infinity an minus 1 into x power n. Okay, this is what? Minus 3 into summation n equal to 1 to infinity n into 2 power n equal to 0. Okay, I think here it is fine, n, but here I n minus 1 n. So make it, this is what? N minus 1. I will write maybe in the next slide. Summation n equal to 1 to infinity an x power n minus 4x summation n equal to 1 to infinity an minus 1 into x power n minus 1. Okay, minus 3 into n is starting from 1. 1. I think here I forgot to multiply by x power n, which is equal to 0. When equal to 1 means 1 into 2x, that is 2x, plus n equal to 2 means what? 2 into 2x whole square. And then plus n equal to 3 means 3 into 2x whole cube, plus and so on, dot, which is equal to what? 0. Now, next step. Okay, so here it starts from the first term because a1x. Suppose if I write this is g of x, I need to subtract the first term. What is the first term? A0. Okay, now actually this is starting from the first term. Okay, because a0 it starts from the first term. That's why directly you can write this is what? G of x minus take 2x common, so minus 6x into 1 plus 2 into x. X is what? 2x plus 3x square, 3 into 2x whole square plus and so on, which is equal to 0. Now you should collect the terms which contains g of x separately. Get what? 1 minus 4x a naught. What is a naught? 4 minus 4, okay, equal to 6x, okay, 6x into 1 minus 2x whole power minus 2. Now 6x, sorry, g of x into 1 minus 4x, which is equal to 4 plus 6x divided by 1 minus 2x. Now g of x is equal to 4 by 1 minus 2x. Okay, I'll write in the next slide. G of x is equal to 4 by 1 minus 4x. Okay, plus 6x by 1 minus 4x into, I think here should be what? 1 minus 4, 2x whole square. So 1 minus 4x into 1 minus 2x whole square. Okay, now I don't disturb this term. Apply partial fraction for this term. So 6x by 1 minus 4x into 1 minus 2x whole square, which is equal to a by 1 minus 4x plus b by 1 minus 2x plus c by 1 minus 2x whole square. So now, so using partial fraction, you should find the value of a, b, c. A is 6, you can check it. B is minus 3. C is what? Minus 3. Okay. So now g of x is equal to, okay, already here, this is the first term. Okay, 4 by what? 1 minus 4x. This one you can write a is what? 6 by what? 1 minus 4x minus 3 by 1 minus 2x plus, sorry, minus 3 by, again, minus 3 by, okay, 1 minus 2x whole power 2. So now totally this is 10 by 1 minus 4x Okay, 10 by 1 minus 4x. Okay, minus 3 by 1 minus 2x. Minus 3 by 1 minus 2x whole square. Or g of x is equal to 10 into 1 minus 4x whole power minus 1 minus 3 into 1 minus 2x whole power minus 1 minus 3 into 1 minus 2x whole power minus 2. Now expansion 10 into 1 plus 4x plus 4x whole square plus dot 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 plus 4x whole power n plus dot dot dot. Okay, now next minus 3 into 1 plus 2x plus 2x whole square plus dot 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 plus 2x whole power n and so on. And third one minus 3 into 1 plus 2 into x, x is 2x plus 3 into x square, x is what, 2x square plus dot 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 nth term n plus 1 into 2x whole power n plus dot 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 close the bracket. Now okay, g of x is equal to, so okay, this is actually what g of x. Now compare the coefficient of x power n on both sides, we get a n equal to 10 into 4 power n, 10 into 4 power n minus 3 into 2 power n minus 3 into n plus 1 into 2 power n. So a n, just simplify, a n equal to 10 into 4 power n. I think here minus 3 into 2 power n is common. Minus 3 into 2 power n is common. Remaining have what? 1 plus or minus plus, yes, plus n plus 1. Okay, the next step we can write the answer. So a n equal to 10 into 4 power n minus 3 into 2 power n into n plus 2. So this is the final answer. So we'll do one more problem if time permits. Still 7:53. Okay. Yeah, next problem is use the method of generating function to solve the reconciliation a n equal to a n minus 1 plus 2 times n minus 1, where a naught equal to 3, n greater than 1. I will write the problem here. Next problem, fourth problem. Solve, okay, using the method of generating function. Okay, use the method of generating. So today what I solved all the problems are using generating function. We solved the recurrence relation. To solve the recurrence relation, RR recurrence relation, a n equal to a n minus 1 plus 2 times n minus 1 where a naught equal to 3 and n is greater than or equal to 1. Solution. Let g of x be the generating function of the sequence an is what? Summation n equal to 0 to infinity an x power n. Okay. So now just to rewrite this equation, minus an minus 1, and you can keep 2 into n minus 1, or you can write split. You can split how you can write minus 2n left hand side plus 2 equal to 0. Now taking the summation, multiply throughout by x power n and taking the summation n equal to what? 1 to infinity. So n equal to 1 to infinity an into x power n minus summation n equal to 1 to infinity an minus 1 into x power n minus 2 is constant. So summation n equal to 1 to infinity n into x power n plus 2 is constant. Summation n equal to 1 to infinity into x power n equal to 0. So I think here n is perfect. Here what? n minus 1. So summation n equal to 1 to infinity an into x power n minus take x common, summation n equal to 1 to infinity an minus 1 into x power n minus 1 minus 2 into, if I substitute n equal to 1, you get x plus 2 means 2x, 3 means 3x square, plus and so on. Plus 2 into n equal to 1, x, 2 means what? X square, 3 means x cube, and so on, which is equal to what? 0. Now, suppose if I write this is g of x, okay, suppose if I write this is g of x, here it starts from the second term. A1 means second term. So that's why I subtract what? A naught minus x. This is start from the first term because A naught is start from the first term. That's why I'll write g of x, which is equal to, I'll write everything in the right hand side. 2 into take x common. So then we'll get what? 1 plus I think here 2x. I think I done the mistake here. Maybe yes, but n equal to 1 now. 1 into x. Next n equal to 2 means what? 2x square. N equal to 3 means what? 3 into x cube. This is x cube. So if I take x common, I'll get what? 1 plus 2x plus 3x square plus and so on. Okay, this is actually what? X cube. Now I'll write this on the right hand side, minus 2 into, okay, I think if I take x common, 2 minus 2 into x, 1 plus what? X plus x square and so on and so on. Okay, now if I take g of x common, g of x into what? 1 minus x. G of x into 1 minus x. What is a naught? A naught is 3 minus 3, okay, which is equal to minus plus 2x into 1 minus 1 minus x whole power minus 2 plus 2x 1 minus x whole power minus 2, and then minus 2x into 1 minus x whole power minus 1. 1 minus x whole power minus 1. So now g of x into 1 minus x, which is equal to 3 plus 2x by 1 minus x whole square plus 2x by 1 minus x whole power 1. Okay. What is g of x now? So 3 by 1 minus x plus 2x by, I think here it should be what? Minus r. It should be minus. Okay, plus 2x by 1 minus x whole power 3 minus 2x divided by 1 minus x whole square. Or you can write g of x is equal to 3 into 1 minus x whole power minus 1. 3 into 1 minus x whole power minus 1 plus 2x into 1 minus x plus 2x into 1 minus x whole power minus 3 minus 2x into 1 minus x whole power minus 2. Now expansion. So 3 into 1 plus x square and so on plus x power n and so on. This is over plus 2x into 1 minus x whole power minus 3. Already I told that it should then write 1 by 2 into 1 into 2 plus 2 into 3 into x plus 3 into 4 into x cube and so on. Here I have a x term, so here I need x power n minus 1 term. What is x power n minus 1 now? Here n into n plus 1 into what? X power n minus 1. Okay, I don't need the nth term here because here I don't have x square here. Sorry, I don't have any constant term. Okay, anyway, I'll write n plus 1 into n plus 2 into x power n plus and so on. So next minus 2x into 1 minus x whole power minus 2. 1 plus 2x plus 3x square plus 4x cube and so on. Again, here I need here x na, here I need x power n minus 1th term. Okay, x power n minus 1th term is what? Here n into n into x power n minus 1 plus n plus 1 into x power n. X power n. This is x. Okay, x power n plus and so on. Now compare the coefficient of x power n on both sides. We'll get an equal to 3 into 1. Okay, plus 2 gets cancelled. Here x power n minus 1 means x power n plus n into n plus 1. N into n plus 1. That is the coefficient of x power n. And then here x power n minus 1 is what? Minus 2m. Minus 2m. So an equal to n square minus 2n plus n is what? Minus n plus 3. So this is the final answer. So an equal to n square minus n plus 3. So okay, now maybe I'll check the time again. Okay, 8:4. Okay. Now, okay, I will explain using the PDF. This PDF. Maybe actually this is something a lengthy problem, but just I will tell you uh, because here, okay, so see here, here it can nearly it has A, B, C, D, E, F, G. So we need to find 7 constant. So I feel this is somewhat lengthy problem, but the book Virajin book it has a solution. So use the method of generating function to solve the recurrence relation an plus 2 minus 4 into what? An equal to 9n square, where n is greater than or equal to 0. So g of x is what? The generating function n equal to 0 to infinity an into x power n. So now multiply throughout this equation by x power n and taking the summation n equal to 0 to infinity. That is the first step. Second step, here n plus 2, here n means here I need n plus 2, that's why I divide by x square and multiply by x square. So I'll get 1 by x square summation n equal to 0 to infinity an plus 2 into x power n plus 2. I think here it is fine. So that's why I'll write what? G of x minus n square minus 9 into summation n equal to 0 to infinity. Here I do some trick, add and subtract n square plus n minus n into what? X power n. Because if you keep as it is, you cannot get a nice form. You cannot apply what? Binomial expansion. That's why they will add and subtract here. Now 1 by x square into, if I write this series is g of x, it is starting from a2. A2 is what? Third term. So if I write this series is g of x, then I need to subtract what? First term, this is the first term, this is the second term. So minus 4 into g of x minus 9 into summation n equal to 0 to infinity. Here I'll take n is common, the first two term. So then n into n plus 1 minus n into x power n equal to 0. Now I'll take g of x common. So, or you can throughout multiply by x square, okay, but there is no need to multiply by x square, okay. Uh, so take g of x common. So, to take g of x common, 1 by x square minus 4, and then what? Minus a naught by x square plus a1 by x. Okay, here x square a1 by x minus 9 into summation n equal to 0 to infinity n into n plus 1 into what? X power n, and then plus 9 into summation n equal to 0 to infinity n into x power n equal to 0. Okay, next g of x into 1 by x square minus 4. I'll write everything in the right hand side. This is equal to a naught by x square plus a1 by x plus 9. It goes right side. N equal to 0 now, everything is 0. N equal to 1 means what? 1 into 2 into x. N equal to 2 means what? 2 into 3 into x square. So it goes like this. If this is going to right side, minus 9 into n equal to 0 means what? 0. N equal to 1 now, 1 into x. 2 means what? 2 into x square, and so on. Okay, now take x square is LCM. So g of x into 1 minus 4x square by x square, a naught by x square plus a1 by x. I took, I think here, okay, I took x is common. So x is common now, what you will get? 9x 1 into 2 plus 1 into 2 plus 2 into 3. Here x is not x square. Okay, I done the mistake here. This is what? X power 1. Okay, this is it's not x square because I took x common, 2 into 3 into x. And here, what is the coefficient of x power nth term? N into n plus 1 into x power n, but I took x common, that's why I'll write here what? N into n plus 1 into x power n minus 1. Here I'll take x common, so minus 9x into 1 plus 2x plus 3x square and so on. So why I'm not here, why I don't take 2x common? The reason is in the 1 minus x whole power minus 3, the first term is what? 1 into 2. That's why I'll take x only common here. Okay. So, and then I think I explained up to this step because here I took x common minus 9x into 1 plus 2x plus 3x square and so on. Right hand side is what? A naught by x square plus a1 by x plus 9x into actually 1 by 2 into 1 into 2 plus 2 into 3x square, that is what? 1 minus x whole power minus 3. That 1 by 2 is not here. That's why here multiply by what? 2. 2 into 1 minus x whole power minus 3 minus 9x into what? 1 minus x whole power minus 2 and then 1 minus 4x square into g of x throughout multiply by x square. Okay, wow. So a naught plus a1x plus sorry here throughout to multiply by x square means 1 minus 4x square into g of x and then a naught a1x 18x already now x square we are multiplying 18x cube by 1 minus x whole cube minus 9x into x square 9x cube by 1 minus x whole square. Okay. Now g of x is equal to a naught plus a1x by 1 minus 4x square plus 18x cube by 1 minus x whole cube into 1 minus 4x square minus 9x cube by 1 minus x square into what? 1 minus 4x square. Okay, I think I keep this is same. Here I took LCM. What is LCM? 1 minus x whole cube into 1 minus x whole square. But here I have what? 1 minus x whole square into 1 minus 4x square. I think this is same, but here whole cube, here whole square. So 18x cube minus 9x cube into what? 1 minus x. So there is no change here. 18x cube minus 9x cube is what? 9x cube and then plus 9x power 4. The denominator I will write here 1 minus 2x into 1 plus 2x, here 1 minus x whole cube into 1 minus 2x into 1 plus 2x. Now this is g of x. I'll take the right hand side, that is equal to instead of this I'll write what? A by 1 minus 2x plus b by what? 1 plus 2x, and then instead of this c by 1 minus x plus d by 1 minus x whole square plus e by 1 minus x whole cube plus f by 1 minus 2x plus g by 1 plus 2x. After finding the value of a to g, and then you need to simplify further. Okay, that part in the PDF that is available in the Veerarajan book also. Okay, maximum will take 2 to 3 minutes. I will just finish it. The recurrent solution using generating function. Maybe tomorrow I'll start mathematical induction. Unit number 3. Okay. This is recurrent solution of recurrent solution. EPT. Yes. Yes, I think this problem. Example 2.24. So I think how like I think I explained maybe in this slide. Okay, and the PDF you can check it, or you can refer Veerarajan book. You get the answer. And I don't explain 5.91 this problem. An equal to 3 into an minus 1 plus 2 where n greater than equal to 1 with a not equal to 1. So I feel this problem is slightly easier. That's why I skipped this one. And then I don't explain this problem also. An minus 2 into an minus 1 minus 3 into an minus 2 equal to 0. Okay, you can try to solve this problem. Then I explained this one 5.94. I don't explain two problems. I think there is some mistakes here in this problem. So we got some other answer. I think we got what? I think we got yes, n square minus n plus 3. But here 2n square plus 3. I think this is a mistake. We got what? We got n square minus n plus 3. The same problem. Okay. So an equal to an minus 1 plus 2 into n minus 1. Okay. So there are some typos in the PDF, the book. Okay. Next, I think here some of the practice problems from 55 to 60. Okay, you can try to solve. It is also in the Veerarajan book. Okay, but solution only there. So you need to do it and verify the answer. I'll stop here. If you have any doubts, you can ask to me. Okay, thank you.